Hello, everyone. Good afternoon. This is a technical session 1D, and myself, Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Conference on Information and Communication Technology for Comparative Strategies. In this session, we have 8 presentation. Each presentation will be allocated 8 minutes for presentation and 2 minutes for question answer. After 7 minutes, I will raise a gentle reminder to conclude your presentation. I hope this session will be informative enough. And in this session, I request to everyone kindly stay connected till the closing remarks. So in the end of the session, we can take a one quick snapshot for making this virtual session more memorable. So I would like to invite, just before we get started, I would like to invite our chair of this session, Dr. Swati Nikam. Dr. Swati Nikam has a total 20 plus years of teaching experience in computer engineering and working as a head of Department of Artificial Intelligence and Data Science Engineering in Dr. D.Y. Patil Institute of Technology, Pune, India. She completed PhD from SPPU Pune. Her research area are cyber physical system, information security, and Internet of Things. She has published more than 30 plus research paper in a reputed international general and conferences. Also work as a session chair, PC chair, associate editor, and a reviewer for various national international conferences and generals. Also, she is working as associate editor of International General ICICT. Welcome to you, ma'am.
Thank you, Richa. Thank you so much.
And now I would like to start with papers. Now I would call our first presenter to present her paper on a study of breast cancer identification with deep learning techniques. The presenter name is Sujita Priya. I think this presenter is not here, so we can call our next presenter, Subhanshu Gautam. To present his paper on classification of heart signal using variational mode decomposition.
Ma'am, I am audible?
Yes.
Okay. Ma'am, my screen is visible, ma'am.
Yes, your screen is visible.
Ma'am, it's visible, ma'am?
Yes, yes.
Okay, thank you. Good afternoon, everyone. My name is Subhanshu Gautam, and my topic is classification of heart signal using variational mode decomposition. And these are the agenda for this presentation. Introduction, objective, literature survey, system overview, methodology, signal acquisition, pre-processing and feature extraction, classification and performance analysis, system requirement, and conclusion and references. Introduction. Accurate diagnosis of cardiac conditions provide a major impact in reducing the risk factor and death rate. ECG is a test to strength and timing. ECG is a test. ECG is a test to detect the strength and timing of the electrical activities in our heart. Variational mode decomposition in biomedical application is the latest signal processing tools where the input signal is decomposed into different IMFs. IMF means instructive mode functions. Instructive mode functions are amplitude and modulated instructive mode functions are amplitude modulated and frequency modulated signals. Recording and monitoring of heart signals has a great importance in medical field. Conventional method for recording these signals are are mostly expensive, affected from the environment conditions and trouble for the patient. Empirical mode decomposition method could get us will not get a satisfactory result if the noise were present in the EC signals. While performing the EMD, we have to specify the number of modes. If the number of modes provided is not that actually required, it may result in mixing of signal components into the given number of modes. Objective: use of variational mode decomposition techniques over the popular EC signals for removing noise and improve accuracy, and detect the normal and disordered signals and check whether the person is normal or abnormal. Literature survey. Paper first in paper first in paper first in paper first compare three biomedical denoising techniques based on the recent introduced VMD, variational mode decomposition, EMD, empirical mode decomposition, and DWT, discrete wavelet transform. Based on this peak signal to noise ratio, the result shows that VMD perform best over the EMD and DWT. In paper second, the main difference between the method is that EMD method is more sensitive towards the lower frequency present in the signals, but EMD is less during various cardiac abnormalities. And paper third in paper third, the new method was introduced named as variational mode extraction (VME). VME extract only specific modes through knowing its center frequency. Um, VME is a good tool in application of extracting the specific mode, such as EDR problems. In paper fourth, the approach of the separation of heart and lung sound (HLS) is proposed based on the nonlinear decomposition techniques VMD VMD of PCG signals. The proposed method is found that is found to perform better than the conventional methods such as empirical mode decomposition or assemble EMD and different versions of EMD. System overview. Recording and from the system overview. Recording and monitoring of heart signals from the given input signals. These recorded signals are further passed through processing or filtering method using VMD techniques. The EC signals is decomposing into different IMFs. And the health state of the heart is classified based on the feature expressions of IMFs. Data description. In this section, we introduce the MIT BH arrhythmia data set and the proposed method, proposed heartbeat classification approach. MIT BH arrhythmia data set is one of the widely used data set for the study of arrhythmia classification. MIT arrhythmia database is mostly used for medical and research purpose for different heart arrhythmia detection. Methodology: collect existing ECG data on that basis. On that basis, data set as per the required as per the project requirement. Using VMD technique, the ECG signals is decomposing into different IMFs. Modes given by VMD considered as amplitude and frequency modulated signals. After extracting from each modes, different classifiers are trained and tested with a SVM classification. Health state of the heart is classified based on the feature extractions from the IMFs. We check the person's heartbeat, whether the person is normal or abnormal, and estimate the performance using VMD. Signal acquisition. The signals labeled in these examples are from arrhythmia data set, and signals is based on signals in the database was sampled at 360 hertz. Signal preprocessing. And the aim of the preprocessing is removing noise. Using preprocessing, removing noise, remove white noise from the ECG signals. IMFs. These are the different IMFs. VMD method is measured by signal to noise ratio. Therefore, first IMF contain the most noise, and last IMF 9 give a clear signals. Signal variational mode. Hilbert transform. I applied the Hilbert transform for this project. Hilbert transforms is important in signal processing, where it drives the analytical representation of signal as analytical signals, comparing comparing the original functions and its Hilbert transform. And power spectrum density. In this given figure, the power spectrum density of the signals describes the power present in the signals as a function of frequency as a function of frequency per unit frequency, and a power spectrum density is considered commonly expressed in watt per hertz. Uh, signal variational mode. From the given input signal, given input, these are the four different modes named as VM1, VM2, and VM3 and VM4. Feature extraction, extracting the features such as energy, entropy, variance, RR interval, mean, and standard deviation from the given ECC signals. And from the four different variational modes, we can get different variational mode features and test features. After feature extraction, we estimate using classification. We estimate the patient as normal or disorder. From the given picture, it is clear that the given patient is disordered signals, and we estimate the accuracy. And feature classification, system feature extraction. Then system requirement for this project. I use minimum hardware requirement is Intel Platinum, and minimum RAM 2 GB, and software requirement I use MATLAB, and operating system is Windows. Conclusion is VMD implement in MATLAB, and 9 IMFs has been observed, and each IMFs are distant. And it is seen that the accuracy of the system adaptively increased by this VMD based techniques. These extracted features are classified using SVM classification, and these proposed work achieved the accuracy of 95%, 97.5% in comparison with the other methods. These are my references. Thank you. Hello.
Yes, thank you for your presentation. I have one question.
Yes, ma'am.
Can you tell me any negative point or any challenge with this methodology which you have faced?
Negative point, ma'am, is that, ma'am, as if ma'am, as compared to EMD, in some point of time, ma'am, there are different types of non-linear techniques are there. VMD, as assemble EMD, and variational mode decomposition. So in some point of time, EMD is also performed good for higher frequency, and EMD is good for lower frequency. That is the main drawback. Like VMD is performed give good result with lower frequency, as compared to EMD is give good results in higher frequency. So that is the drawback, or as I can say that, ma'am.
Okay. And one more question is, you said the accuracy is increased, you got till 97.5%. So what are the other accuracies? I mean, what are the other results? Have you done any comparative analysis?
I'm not comparing with others techniques like EMD or assembled EMD. I only use, ma'am, a variational body composition. I didn't compare EMD or accuracy with VMDs, ma'am. I only use VMD according to I apply from the given VMD I after pre-processing filtering I distribute into modes. According to that I get the features like variation, standard deviation. On that basis I use ML algorithm and classify the signal. Classify the signals is normal, abnormal.
So, but ideally, you should do some comparative analysis when you are claiming that that's the best method. So, okay, thank you.
Thank you so much.
Now we can call our next presenter to present a paper on crop-specific cultivation recommendation system using deep learning. The paper presenter is P. Parmeshwari.
Can I share the screen, ma'am? I'm audible.
Yes.
I can't able to share the screen. You can't start screen sharing while the other participant is sharing.
Okay.
Now is it visible, ma'am?
Yes, it's visible.
Shall I start?
Sure. Yes, please.
Okay. So good afternoon all. So I'm Dr. Parameshwari from Kumaraguru College of Technology, and my topic is about crop-specific cultivation recommendation system using deep learning. That is the basic need for this type of research. As we know, the agriculture sector contributes more than 17% of our GDP, and so due to unscientific farming practices leads to low productivity in agriculture, and because of lack of knowledge in crop selection and farming. If we have an improved crop management system, our yield can become higher. The crop recommendation is one of the agriculture's most difficult challenge, and various versions has been put forward to proven thus far. So that is the main need for this type of research. Another one is yield production is affected by a range of issues such as because of climate, weather, soil conditions, seed diversity, and this challenge necessitates the usage of some information. If we take the crop recommendation models, it can be accurately estimate the true yield, but also a better crop recommendation procedures. It can be required. So nowadays, each and most of them, everybody is using smartphones. Can have daily, they can see the updates, whatever happening around the world. So there are for this particular type, this type of applications, we have numerous machine learning algorithms which can be used to recommend the crop cultivation or yield predict, extract information that was being needed in farming. So our objective is farmers' need is to deal with many problems. As we know, where there are a lot of climatic related issues, water scarcity. There are a lot of issues. So our objective is to have give us small application that to the farmer that can help them to make decisions before going for cultivation. So choosing the right crop to grow and enhance crop cultivation is an essential aspect, and it improve real life farming scenarios. So that they are not in a position to select the proper crop that suits for their particular farm. So just like that, based on the trends or based on somebody's advice, just like that, they used to choose the crops and they used to cultivate it. So this research, this type of researchers can help them to make a better selection. So this main objective is to recommend the farmers the best crop that suits for their farms. So based on the soil, nature of their soil and the temperature, the humidity, rainfall, and soil pH. So everything was being taken into consideration for a recommendation. As per the literature, we have the first paper talks about the farmer can use the precise crop prediction model to assist and decide on crop patterns. And this particular research will give the specific time to grow the plant, and what to grow and when to grow. So that is the timeline when they can start cultivation, and the things, what type of crop they can cultivate, and all these things has been discussed in this particular paper. So the next one is about using artificial neural networks and clustering models, and they have used decision trees also for this type of application. And then rainfall and soil behavior were studied by using k nearest neighbor, and multivariate and linear regression prediction models were also used in this particular paper. And the next paper speaks about it talks about how the prediction forecasting the tradition, that is precise data, that is the traditional, it discuss about the traditional methods, and how it helps for a better decision making to solve some sort of complicated problems. In hyperspectral analysis, various type of neural networks was being used to achieve certain results in this paper. So our proposed system is about, here we are taking using that is decision tree, SVM and RNN models are implemented, and the data sets to calculate that accuracy. The proposed model is here we have proposed a hybrid model that outperforms other models. That is, we have test the data set with decision tree, SVM and RNN. And finally, we have proposed that is, we have combined all those three algorithms, and we come out with a hybrid algorithm, which we found that the prediction accuracy was much more than that of other three algorithms, which was already existing. It was implemented within, it was again, the results was being integrated with an Android application that can be communicated to the farmer based on the details which they are providing for further processing. So as we know, the decision tree algorithm, it's a supervised machine learning algorithm where data is continuously split according to a certain parameter. Support vector machine, it's also nowadays it's a popular and powerful classification and regression algorithm, and it aims to create decision boundaries between classes that enables the prediction of labels from one or more feature vectors. So next, recurrent neural networks, it works on the principle of saving the output of a particular layer and feeding this back to input in order to predict the outputs. Here the nodes in different layers of neural networks are compressed to form a single layer of recurrent neural networks. So this is the block diagram of our proposed model. We have got the data from the Gaggle data sets, and it was trained, and the data was trained, splitted, and one part was being used for training and test. Here we used decision tree, support vector machine, and recurrent. So individually we test the data with decision tree, support vector machine, and concurrent recurrent neural network. So finally, that is, we combined all this model. We have produced a model called hybrid model, which combines all those things. And finally, the result has been validated. And this is the block diagram of our system. And about the data, it was retrieved from the Gaggle repository, and the data is about that is the rain, climate, fertilizer data sets. That is this particular data is from acquired from ICFA, that is Indian Council of Food and Agriculture. Totally, there are 2,200 records in this particular data set. And the properties are like nitrogen, calcium, etc. So each which represents a crop cultivation in a given climate. So this is the results which we have got from this from our research. That is the prediction accuracy in decision tree. The prediction accuracy is 97.27, and from SVM 98.39, RNN 98.85. So, and then the hybrid model gives a 99.4/5, so which is the highest prediction accuracy when we compare this decision tree SVM and RNN. So if we look into the model building time it requires the decision tree is 3 seconds, that is support vector mission 4 seconds, recurrent neural networks of 17 seconds, and hybrid model of 20 seconds. So as we can see that the hybrid model have taken more time. So even though the accuracy, prediction accuracy, that is the accuracy is more, but the time which it took to this process was much higher than that of other 3 classification algorithms. So finally, its major goal is to advise cultivators on good quality crops to plant based on before planting is achieved. And the proposed model has correctly classified 99.45%, and which is also the most accurate. The farmers can also be benefited by the results, and so that they can plan for the cultivation by considering so many attributes like weather, soil, and other. So according to the research, the new hybrid algorithm beats the existing methods, which with good output. Thank you.
Yeah, thank you, madam, for your presentation, wonderful presentation. I have one question.
Yes, ma'am.
Yeah. So have you thought of any practically implementation of this? I mean,
yes, ma'am. Yes, we have actually it's student work. So what we did, we have developed a mobile application, and we have fed this output to that particular application, and then we have worked in it, ma'am. Just they have it. It's there will be a. If I want, I'll show. I can't able to see. Okay, we have developed an Android application, and after that, just we have connected the output to that. So the farmers has to give the details about that, the soil nature of the soil. If they have, they can give, or just we have tried it. It's a trial and trial. Just we don't know that how far it can be implemented.
so what's the practical reach? I mean, are they using it, or you have not yet launched it?
Just it's it's a trial for purpose we have developed, and we have checked it, ma'am. Real time we are not using it.
Okay. Okay. Thank you.
Thank you.
Now we can call our next presenter, Sri Shendu Bhattacharya, to present his paper on determination of resonant mode of equilateral triangular metallic cavity.
Am I audible, ma'am?
Yes.
Hope is it visible?
Yes, it is visible.
So I'm Sri Shendu Bhattacharya, presenting my paper, Determination of Resonant Modes of Equilateral Triangular Metallic Cavity. My co-author is my guide, Professor M. Biswas from ETC department. So these are the contents: introduction, cavity configuration, theoretical analysis, results and discussion, and finally the conclusions. Let me introduce this particular thing, why we are going for that particular topic. For many applications, such as frequency selective components of microwave oscillator, metallic cavities are used, and it was used for long back. It is nothing new in it. The cavity has ability to alter the radiation characteristics of antenna when it is used along with the antenna. Cavity backing can reduce the resonant frequency of the antenna. That implies that the miniaturization of the antenna is also possible. That is also reported long back. Additionally, a cavity can boost the gain of the antenna. That is also reported. These days, cavity-backed antennas are employed in variety of applications like broadband conformal phased array, air surveillance radar, etc. So these type of antenna are well known, and they have many applications. Now, determination of resonant modes of a cavity is very important in order to observe the change of performance parameters of the antenna when it is enclosed by cavity. To the best of our knowledge, theoretical analysis is not available for equilateral triangular cavity, though different type of cavities are there, like circular cavity, rectangular cavity. The analysis for those cavities are actually available, but since we are working with triangular patch antenna and triangular cavity back patch antenna, so we need to know what are the different modes of a cavity, triangular shaped cavity. So this is our motivation, that we don't have any kind of theoretical analysis, basic theoretical analysis for triangular cavity, and we are doing it. So in this article, the theoretical analysis for determination of resonant modes of equilateral triangular cavity is first carried out, which is then validated with an electromagnetic simulator. Here we have used the CST simulator. So this is the configuration of our cavity. So this is actually the cavity. This is the top view, and this is the side view. So this one is actually the cavity. This hollow space is the cavity. The probe is inserted from the centroid position of the triangle. This is the centroid position of the triangle. So we have inserted the SMA connector from here. And for the simulation purpose, we have used brass as the material of the cavity. The thickness of the cavity means this one. This is the thickness of the cavity. It is taken as 5 millimeter. And the thickness of the ground plane, this one. This is the thickness of the ground plane. This is taken as 4 millimeter. The probe, outer radius of the probe is 2.032 millimeter, and the inner radius, this one, inner radius is 0.625 millimeter. Now let us go for the theoretical analysis, and I have omitted most of the mathematical part because that part is extremely boring. But I will just want to highlight a few things only. To determine the resonant modes of a cavity, first of all, understanding of mode configuration of the corresponding waveguide with the same shape is required. That means if we want to get the mode of a triangular cavity, we have to first understand the resonant mode of a waveguide, corresponding waveguide. So basically, when we truncate a waveguide, that becomes a cavity. So that's the idea. So to determine the modes of equilateral triangular cross-section waveguide, this is the following procedure is followed. By reflecting about the three parallel lines of the side of, say, these are the parallel lines, these are the lines of the sides of the triangle that cross the opposite vertices, and equilateral triangle's mode function can be extended to three surrounding equilateral triangles. Like if we have knowledge of over this particular triangle, we can easily get the knowledge for this particular triangle, this one and this one. So this was the basic idea. And this function defined in this new region can be endlessly extended by analogous reflection. Like if we have these small triangles, this consists of 4 triangles only, we can extend the same idea for large number of triangles. So we can have this idea for extended region of space. And the extended mode function is periodic in nature. If h is the length of the perpendicular from an apex of the adjacent side, the periodicity interval will be of the order of 2h, which is equal to √3 times of s. S is the you can see this s. This is the s, internal side length of the cavity. Now for an electric mode, the mode function can be written in this form. I am omitting this particular section. So, and we are taking the new 3 unit vectors, P1, this is P1, this is P2, and this is P3. So these are the expressions. The periodic function FR on the plane with the position vector R, that can be expressed in this way. Sorry. If gamma is the cutoff wave number of the mode, then assuming exponential solution of the form FR equal to e to the power I gamma R, that means that we are taking the complex solution, then FR will take this type of form, right? And if we assume 3 integers L, M, and N, and that satisfies the condition L plus M plus N equal to 0, then from the knowledge of this FR, we can get the corresponding gamma square. That means the square of the cutoff wave number, and it found out to be this one. And after getting this gamma, we can get the corresponding frequency for the waveguide. This is the frequency for waveguide. Now, when the waveguide is used as cavity, the length of the guide L must be finite, and obviously it is of the order of the wavelength. And its application of the boundary condition at the open end gives the expression for resonant frequency. So this is actually the resonant frequency of the cavity. Note the difference. Here we have FRNM only. These are the mode configuration. But once we cut down the waveguide and we'll use it as cavity, so we have some the third dimension will come into the picture. So here we have FRMNQ. So this new integer q will come into the picture, and this is coming according to this expression. Okay, so this is our final expression for the resonant frequency for the cavity, triangular shaped cavity. Now what we did, we have used CST simulator of different shape and different size and dimension. Just one example is shown right here. As you can see, it is plotted in the x-axis we have frequency, and y-axis we have the S11 parameter, and we have got certain deeps, right? So these deeps are actually indicating the modes. Different type of modes are there. So this particular figure shows that the existence of various modes inside the cavity. And here we have the comparison table of resonant frequencies for a cavity with length, rather the wall height of 15 millimeter. So as you can see, so if we take different cavity side length, 10 millimeter, 20 millimeter, 30 millimeter, etc., we will get different modes. For each case, we will get different modes. So this is the simulated result, so 36.37, and we tried to map that particular frequency with our theoretical model, theoretically determined frequency with various m, n, and q. And as you can see, for 1, 1, 2, m equal to 1, n equal to 1, and q equal to 2, we are getting 36.05. So it is very close to the simulated results. So in this way, we tried to map all the simulated results with the theoretically obtained results, and they are showing good matching between the theoretical value and the simulated value. Now we have done this whole thing for various side lengths like S equal to 20 millimeter, 30 millimeter. Also, this is actually the continuation of this particular table. And we have omitted some portion of the table, obviously, because of the lack of space. So here also you can see that this one is for 45 millimeter, 30 millimeter, and wall height is 45 millimeter. So this 45 millimeter, and the first mode is occurring at 11.64. This is the simulated result. And with our model for 111 mode, we have 11.66.
Dear presenter, you have last 1 minute left.
Okay, thank you. I'm concluding. So the theoretical analysis for equilateral triangular cavity is carried out to determine the frequency of different modes. CST simulation is also performed for triangular cavity with various wall height and side length. Comparison of simulated and theoretical frequencies for different modes are done for those cavities. Theoretical and simulated results show good resemblance. The future scope of this work may include the following aspects: that is, the investigate of radiation pattern, impedance bandwidth, then investigate the effect of cavity parameters on the performance parameters of the patch antenna backed by cavity, and so on. So these are the references. Thank you.
Yeah, thank you for your presentation. I have one question, like, what is the practical significance of this research?
Okay, so actually in the first slide of the introduction, I have said that we have different applications. Even those applications are highly complicated applications, like in radar or phased array radar. We can use this type of antenna. So once we want to use this type of antenna, cavity backed antenna, first of all, we have to understand the different the characteristics of the cavity itself. Without knowing the cavity, we cannot use it in connection with the patch antenna. Now, our research motivation is that we don't have any idea so far. We don't have any idea about the triangular cavity. So this is the first time we are trying to get the modes of the triangular cavity. Okay, so that's a completely new thing. In previous days, circular or rectangular type of cavities were investigated, but we are trying to investigate the triangular cavity so that we can use it along with the triangular shaped patch antenna. We have got certain advantages of triangular shaped patch antenna. So we are not, we haven't discussed those parts actually, because right now we are discussing only the cavity part. But ultimately, this particular cavity will be used and along with the triangular shaped patch antenna. So that is why we need to know the frequencies and other parameters.
Okay. Yeah. Thank you.
Okay. Thank you.
Now we can call our next presenter, Biplav Biswa, to present his paper on investigation of miniaturized microstrip patch and antenna for metamaterial application.
Good evening. I am Biplav Biswa from Chandigarh University, Kolkata. Our research work titled Investigation of Miniaturized Microstrip Patch Antenna for Metamaterial Application. Paper ID 258. Under the supervision of Professor Manata Research, Department of ETC, and Professor Sanjay Kumar, Department of Physics, Chandigarh University. The motivation of this work: several work have been done on ring resonator antenna. Among them, most of the articles are rectangular, circular, square patch antenna. To the best of our knowledge, the equilateral ring resonator antenna have not yet been studied. But an article proposed by Barco and Sapai have been determined the performance parameters such as resonant frequency, input impedance, bandwidth, and directivity of a square ring resonator antenna. In this article, we have designed a equilateral triangular ring resonator antenna using a finite element method software or HFSS. Here we have presented the variation of resonant frequency, input impedance, and gain with the variation of width of equilateral ring antenna. The resonant frequency decreases gradually with the progressively decreasing the central conducting portion. Thus, the equilateral ring resonator antenna behaves like a pressurized antenna. Some references are below. Our proposed design here. This is the ground plane. The ground plane thickness 0.03 mm and epsilon. This is the substrate. The substrate height 1.575 mm. Epsilon r is the substrate permittivity. Here the equilateral ring antenna. The A1 is the outer ring side length. A2 is the inner ring side length. W is the width of the ring. Rho is the probe feed location. The feed insert 2 mm from the tip of the ring. Results. In figure 2, we have presented the variation of resonant frequency with the variation of the side length of the inner ring. The resonant frequency gradually decreases with the ratio of A2 divided A1. That is increasingly removing the central conducting portion. So the antenna miniaturized is occurred. For an example, when A2 is 30 mm and A1 50 mm, then the frequency, resonant frequency, we get 1.94 gigahertz, which is corresponding to a solid patch of side length 65 mm. When we can see that from the figure, when A2 divided A1 is increasing, the frequency dramatically decreases. The variation of resonant frequency with the variation of A2 divided A1 equilateral ring antenna. A1 50 mm, A2 is variable. H1 A is equal to 1.575 and epsilon r is equal to 2.30. Figure 3, the variation of input resistance with the variation of A2 divided A1 of equilateral ring antenna. The input resistance gradually decreases. The input resistance gradually increases with increases the A2 divided A1. We can see that when A2 divided A1 increases, then the input resistance increases. Figure 4 shows that the effect of A2 divided A1 on a resonant frequency and input impedance. The resonant frequency dramatically decreases with the increase of ratio A2 divided A1, but the input resistance increases with the increases of ratio of A2 divided A1. We can see that from the figure, resonant frequency decreases, but the input impedance increases. Figure 5, we can see that the gain decreases with increases of A2 divided A1. That is increasingly removing the central conducting portion. When central conducting portion decreases, then the gain decreases. This is based on the fact that the side length of the antenna is reduced due to progressively reducing the central conducting portion of the patch, thus the effective aperture area is reduced, so the gain is reduced. The radiation pattern of the equilateral ring is depicted in figure 6. The plots shows that both of the co and cross polarization gain are decreases when the increasingly reducing the central conducting portion. From E plane, this is the co-pole and this is the cross pole for 50-0 patch antenna, and for 50-30 patch, this is the co-pole and this is the cross pole. For H plane, 50-0 patch, this is the co-pole and this is the cross pole. For 50-30 patch, this is the co-pole and this is the cross pole. The variation of gain and the variation of the angle, the equilateral ring antenna, A1 is equal to 50 mm and A2 is very good, and A is equal to 1.575 mm. Epsilon r is equal to 2.33. Bit location 2 mm from the tip. Tangent 0.001. Conclusion. In this article, we have thoroughly studied the variation of resonant frequency, input impedance, and gain with the variation of dimension of the equilateral ring antenna. The resonant frequency and gain decreases, whereas input impedance increases, with increasingly removing the central conducting portion of the patch antenna. Thank you.
Yeah, thank you for your presentation. Again, the same question is, what's the practical significance of this research? Where would it be specifically used?
Okay. Equilateral patch antenna basically used in microwave component, missile, satellite, radar, invisible submarine, aircraft, etc. Because these have several attractive features such as low in cost, light in weight, reduce in volume, easy to fabricate, and we can miniaturize the microscopic pairs. That means we can miniaturize the volume of the pairs. Those attractive features we can use different microwave instrument collateral pairs.
Okay, thank you.
Thank you.
Now we can call our next presenter, Deepti Dalal, to present her paper on traffic congestion using deep learning models.
Hello. Good evening. Good evening, Swati ma'am, Dr. Swati, and everyone present in the meeting. First of all, I'd like to apologize for the mistake in my title. The title is actually Traffic Congestion Prediction Using Deep Learning Models. And I'd like to give you an overview of my entire paper. Traffic congestion is one of the biggest problems faced by us. And congestion is a result of numerous factors such as our place of residence, mode of transport, land, use of land, city planning, etc. And all of which affects the travel cost, air quality, traffic safety, fuel consumed, and most importantly, the time wasted. Thus, if detected or predicted early enough, this congestion can be avoided or at least significantly less. Various factors such as traffic volume, the traffic density, sensor occupancy, average travel time, traffic speed, the period of the day, etc. affect the traffic flow and congestion conditions. All these factors can be combined into a single factor known as the lane occupancy rate. Since the traffic data, and as in our case, the lane occupancy rates are historical in nature, that is, data is collected over a period of time having relevance through time, and the values follow a certain trend throughout, we have used RNNs, the recurrent neural networks, for the future traffic prediction, as they are the most prominent deep learning models used on such data. On basis of historic data, the traffic conditions at a similar time on previous days, RNNs can predict the congestion levels with great accuracy. As traffic data is sequential in nature, three variants of RNNs, that is the simple recurrent neural networks, the SRNNs, the LSTM, long short-term memory, and GRU, gated recurrent units, have been used in this experiment. As we can see from the internal structures, the complexity of SRNN is less as compared to the other two. GRU consists of 2 gates highlighted in gray, while the LSTM has 3. So there is more complexity in the structure of LSTM compared to the GRU. Thus, intuitively, we can say that SRNN and GRU take less computation time compared to the LSTM. LSTMs have been used in many researches, while the use of GRU to predict traffic data is very limited. In both of the mentioned papers, the performance of LSTM and GRU is compared using different applications like traffic flow, text prediction, etc. In both the cases, the results of LSTM are better than GRU. Paper 1 also states that GRU benefits only from fewer parameters and early and easier convergence. The data set which we have considered consists of the lane occupancy rates having values between 0 and 1 collected every 10 minutes. The data set is fed to the model in 2 ways. Data set A containing the previous day's data, while data set B consisting of the previous week's data of the same day. The data set we further divided the data sets based on the pre-processing techniques applied to replace the missing data, as shown with the centroid or the kth mean, the mean of the entire data set, or the mean of the previous and the next day. These different data sets are used to train the model and predict the occupancy values for the next day. This is the general flow diagram. And as seen from the flow diagram, after replacing the missing values in the data set, they are fed to 3 models, the SRNN, I'm so sorry, TSRNN, LSTM, and GRU. The models were trained using parameters that gave best results. They are trained to predict congestion levels based on historic data, such as the previous day or previous week, as mentioned earlier. And our paper provides a comparison of SRNN, LSTM, and GRU on this single data set using different pre-processing techniques. Finally, we've used the root mean square error to assess the model's efficiency. Upon testing the models, the following results were obtained. The least value for each type of data set is highlighted in bold, the bold values. We've observed that the GRU and LSTM perform better than SRNN. However, GRU outperformed LSTM in opposition to what was found in the related works and research, except the fourth case. The least RMSE value, that is a result of the best performance, can be seen in case of GRU for dataset A3. The computation time of GRU is also better than LSTM. The displayed figure is a graphical representation of the actual versus predicted values shown in blue and orange respectively when GRU was trained for dataset A3. In the graph, the x-axis denotes the day of the week, while the occupancy rates are plotted on the y-axis. Considering the experiment's results, it can be concluded that for the considered dataset, the least error is obtained when GRU is used. Moreover, the most promising pre-processing technique is the one used for dataset A3. So for this dataset, the entire dataset, the best results are obtained when missing data is substituted with the mean of the entire data. Thus, we can say that traffic occupancy levels are similar irrespective of the day of the week or when averaged over the entire data. In conclusion, I'd like to say that a major challenging task is to calculate the congestion index, the lane occupancy rate in our case, because various factors affect it. However, after proper calculations, RNNs are able to provide accurate predictions of the congestion levels. Both LSTMs and GRUs in RNNs give good results, although the model that performs better is based on the data set, the number of features, pre-processing techniques used, etc. For the chosen data set, the results demonstrate that GRU outperformed LSTM irrespective of the type of input, and the best results are obtained when missing values are replaced with the mean of the entire data set. The applications of traffic congestion prediction can be used to predict and warn users using real-time data on congestion levels so that they can choose an alternate route. This would result in saving time, fuel, etc. And the future scope of the experiment can be extended and converted into the form of a mobile application that gives a prediction of real-time congestion levels. Thank you.
Thank you for your wonderful presentation. I have one question. Like you said, the lane occupancy rate, this is what the measure used, right?
Yes.
And for that, you have to the left side, you have so many options. I mean, so many. So to what degree they are contributing?
Yeah.
So
Ma'am, the data set which we received consisted only of the lane occupancy rate. And they have mentioned that, so that is what, this is the ready-made data set which we received, the PEMS data set collected by the government of USA. However, they have also mentioned that these factors are affecting the occupancy rate. That is why I mentioned finally that the most challenging task in this endeavor is calculating the lane occupancy rate.
Yeah, I mean, so that was not clear, like how it is calculated and to what degree these factors are contributing in this calculation.
Ma'am, that was on the data set.
Okay. And my second question is, you got this data set in the Indian context or?
No, currently this data set, as I've mentioned here, is from the PEMS data set. It is the data set of San Francisco collected by the government of USA. For Indian data, we couldn't, we searched a lot, but we couldn't get a similar data for our application. So we decided to go ahead with this.
So what would you think, like, what would be the difference if you do this research, if you try to apply this research in the Indian context?
If I think one of the major problems which we can face is when sporadic traffic occurs, and that cannot be predicted based on the previous day's data. Some like for I'm from Mumbai, so in Mumbai when there are pouring rains, there is traffic is bound to occur. So that times we cannot predict the data based on the previous day's data. With that is, I feel, one of the major differences which we can face if we consider Indian data as of now.
Okay. Yeah, thank you.
Okay, thank you so much.
Now we can call our next presenter, Prashant Chaudhary, to present his paper on virtual lab for tree adjoining grammar-based research.
Yeah, good evening, Swati ma'am and other ICTCS team. Am I audible?
Yes, you are audible. Good evening.
Yeah. Thank you for giving us opportunity to present our research work. Basically, our topic is virtual lab for tree adjoining grammar-based research. And our area of research is artificial intelligence, natural language processing, and machine translation. This is the outline of the our research work. This is introduction, research and development environment for tree adjoining grammar, experiment and result with tree set, future scope and conclusion. So basically, with the growing interest in tree adjoining grammar is one of the grammar formalism. Noam Chomsky, scientist, has divided the grammar in 4 different divisions: type 0 to type 3, and that is regular grammar, then finite state automata, and other grammars. So the context sensitive grammar and context free grammar. So this tree adjoining grammar is introduced by Arvind Joshi sir in 1975, and in any natural language can be represented by using tree adjoining grammar. This comes under the context sensitive and context free grammar. So this is mainly context sensitive grammar. So we have this is our research area. So basically, in growing interest in tree adjoining grammar, there's a numerous NLP tools has been developed, but despite of great importance to developing these tools, we observe a lack of comprehensive research framework or platform to accelerate sustainable development by sharing knowledge within research community. So this is basically our idea to create the complete framework and research lab to accelerate this kind of research. So basically, we believe tree VTAG, that stand for the virtual lab for tree adjoining grammar, giving the solid foundation opportunity to new scientists, researcher, and NLP researcher to develop complete end-to-end NLP solution. The various NLP solutions can be developed, like machine translation, speech-to-speech translation, any speech technology, text analytics, and any natural language tools like email handling or any sensitive information can be predict. So this is, we have already told the basic introduction of tree adjoining grammar, that is introduced by Arvind Joshi sir. So these are the two mild foundation of tree adjoining grammar: initial tree and auxiliary tree. Actually, tree adjoining grammar can be represented by using tree. Tree is a data structure. So basically, this is our research lab. We represent in any language in the world by using tree adjoining grammar. Tree adjoining grammar is a set of the 5 grammar tuples, that initial tree, auxiliary tree, start symbol, terminal, and non-terminal. So like any tree, we can like in any English sentence that we can represent by using a basic tree. These tree can be qualified initial tree, auxiliary tree. Okay, so this is visible, presentation is visible. Hello.
Hello.
Yeah.
Please carry on.
Yeah.
Yes, we are on.
So by using this particular lab, numerous tools has been developed. Like one tool is developed, we have developed to create the grammar. So like for English, suppose anybody, any linguist or any language expert want to create any grammar, that we provide the tools. So scientifically that language, like in English, we have captured the part of speech tagging, and we have defined the every part of the speech tagging, like noun, objective, and then verb. We have defined certain traits, and that language expert can scientifically analyze, and these object can be transferred encrypted within an environment. So these tools present as an object. So we have represented this, the Jal Mahal is picturesque place built for royal duck shooting parties. This sentence we have represented as a tree, and after that we have converted this into with the help of Hindi grammar, and we have placed the English and Hindi grammar with the use of transfer grammar, and we have converted English sentence to Hindi sentence. So this is the application of the one of the application of machine translation. Okay, so and this is the one of the tool that is used to create the trees and visualize the trees, analyze the trees. And the beauty of this environment is this: if certain expert has created some tree, we have developed the one parser, scientific parser, that analyze the language and automatically given the structure of the language. And we can also provide for the every tree, there is a certain nodes. Tree is the collection of node. For the every node, we have defined the certain feature. Like if I am saying Ram eats mango, in this case, if we convert this or translate it in Hindi sentence, this is Ram aam khata hai. If we place the Sita eats mango, at the place of Ram we place the Sita, then Sita aam khati hai. So this is the change of gender. Ram is masculine, then we have given certain feature to subject Ram, and we assign masculine feature, and after that if we convert this or place the any other object like Sita or any female at the place of Ram, then we place the feminine feature. So suppose Sita eats mango, so output will be generated Sita aam khati hai. So that changes of language nuances can be captured by using these kind of tree and features. Application, I am just going to already told you, this is one of the sentence I have taken. In the philosophy of Kashmir, population is very distinctive. We do the pre-processing, and after pre-processing, we convert stand for tagging for the, and after that we have created our own tag that is part of a speech tagger, and after that we have created some tree vector, and we convert the tree vector in the representation of complete set of the English sentences and complete set of the derivation tree. Then we convert it to the Hindi sentence with the help of transfer grammar. So this is Hindi output. दर्शन शास्त्र में कश्मीर की संख्या बहुत विशिष्ट है. So we convert any sentence from English to Hindi, or if we create some grammar from English to other language, we convert to any sentence from one source language to target language by using this tool. This is the inner picture of the how exactly parser or these things work. And we have conducted one separate experiment. The Intel India has provided the one lab setup in Bangalore, and we have we have converted test our parser by using this Intel India. So this was the experimental setup. We have used Linux, CentOS, and these are the some structure, some setup provided by Intel. And after that, these are the some tree vector we have created, these many trees, and this is the performance of our parser. There's a 2 in X. We have given the number of words like 217 words sentence, 240 word sentence, then 480 word sentence. These are the variation of sentences, and we have tested our parser with respect to in their platform. So some cases, these are given the 18 second, one sentence, 200 word, averagely taking the 18 second. And after that, as soon as sentence length increases like 1000 word sentence, then it was taking 90 second. So this time we have observed. The basically this advantage of this lab is this is database independent. We can easily portable to any database. Loose coupling is in this, any module can be easily plug in with this lab, virtual lab, and we encrypt the rules like grammars. These become the object in object form and encrypt it. So this is very safe to transfer or share. We can also reuse the pre-existing tools. This lab is full of the NLP component. There's just so many tools has been already developed with the help of some other research scientists. We can easily reuse these tools. And future scope is this, like we have analyzed any kind of parser, like we have already developed tag parser. We capture the syntactic dependency that can be analyzed, hide corner parser, then semantic parser. I already told you the semantic feature or variation of the what kind of feature given the impact to parser, then statistical parser. These are the various parser we have analyzed by using the same lab, virtual lab. And in this paper, we have the conclusion is this: we have presented VTAG virtual lab for tree adjoining grammar, and this can be helpful to accelerate the sustainable development by sharing the knowledge within research community. It will provide the opportunity to young scientists or researcher to explore, analyze, develop tag-based tools, technology, and solution. And VTech supports comprehensive framework with this specification, standard, modular architecture, and that can be expandable. Any other scientist, researcher can expand this virtual lab in future. So the benefit of this can improve the research in tree adjoining grammar and natural language processing in the field of artificial intelligence. Thank you. And these are the references.
Yeah, thank you for your wonderful presentation. I have one question that you mentioned. It can be used in re-existing.
Pre-existing.
Yeah. So reuse of existing tools. So what was the challenge in that? To what degree you could reuse?
Yeah, ma'am, actually, there's a several tools developed by different researchers.
Can you speak louder?
Yeah.
Louder?
Yeah. Hello, am I audible?
Yeah, now you're audible.
Yeah. Actually, there's a different tool developed by other researcher. These tools have different specifications, like tagger. Tagger, basically the objective of tagger is the tag the category of any language. Suppose I have developed the English tagger, like Stanford tagger. Then in Stanford tagger has different specification, and somebody want to use this tool, he need to download it, then need to rewrite the interface to check it. So this lab provide the all feature specifications and the different languages set up. So pre-existing tools means the tools which we already developed. These tools need not to develop again. This tool is available with environment or framework. So any researcher can analyze or study or experiment or evaluate these tools, and further can improve these tools, or they can develop their own tool. So the basic training or knowledge will be shared. This is the fundamental aim of our research.
Okay. And my second question is, did you find any exception with the Indian languages? I mean,
Yeah, so ma'am, actually European languages has different kind of grammar formalism, and Indian language has different, like I am Hindi speaker. So in Hindi or Tamil, there's just the basic very different, and there's just some rules. So the language computing, the very difficult field, and it is very difficult to capture the nuances of language, especially in Indian languages. And in Indian languages, like in object, I have already given you example, Ram and Sita. The if we use the two words and two different word that is different background or gender, then the language structure or meanings vary. So capture these nuances is quite challenging for us. Yes, ma'am.
Yeah, thank you.
Thank you, ma'am.
Thank you.
Thank you to other member. And if they can ask any other question, I'm available.
Thank you so much, Prashant, for your presentation. And we have completed our all presentations. And I sincerely thank our author for the excellent presentation and all our participants for being a part of this international conference. Thank you so much. And I would like to also thank our chair of this session, Dr. Swati ma'am. Thank you so much, ma'am, for your valuable time and your presence. And all the presenter would be getting digital certificate via 2 working days via email, and all the papers have already forwarded to the springers, so kindly cooperate with the team of ICTCS, because the publication will be live within 5 to 6 months. And now I would like to request this is the token of appreciation, ma'am, on the behalf of team ICTCS and the Global Knowledge Research Foundation. Ma'am, hello.
Yeah, Richa, you are audible.
I think Swati ma'am.
Yeah, thank you, Richa, for this wonderful opportunity, and thank you to all the presenters for the research, presenting the research precisely, and I wish them all the best for the future research. Yeah, thank you.
Thank you so much, ma'am. And I kindly request to everyone, please turn on their cameras for taking a quick snapshot for making this conference more memorable. Thank you so much, everyone.